All right, guys. I'm hoping that this will come out sounding pretty decent. My headset's not working, so we're going to go through this and we're going to go through it as painlessly as possible. So I told you we were going to skip lesson 7 and we're going to go ahead and straight to 8, adding and subtracting polynomials. Exercise 1 states in A, how many quarters, nickels, and pennies are needed to make $1.13? Now, this type of problem is a special type of problem. It has more than one answer. See, to me, I'm thinking I need 4 quarters plus 2 nickels plus 3 pennies. And that's 50 cents and not a nickel. That would be $1.13. But somebody could come along and say, no, you need 2 quarters, okay, plus 12 nickels plus 3 pennies. So you could come up with multiple answers for this problem. It just is a matter of whether or not which way you want to do it. I gave you 2 examples. I want each of you to come up with one more example for me, okay? Come up with another example of how many quarters, nickels, and pennies are needed to make $1.13. All right, so let's go ahead and continue on to B real quick, okay? So B states, I've got 8,943, and it wants me to write it in expanded form. How many thousands do I need? How many hundreds do I need? How many tens do I need? How many ones do I need? So I look. How many thousands are there? There's 8. How many hundreds are there? There's 9. How many tens are there? There's 4. How many ones are there? There are 3. So there are 8 thousands, 9 hundreds, 4 tens, and 3 ones. Okay? Now, look at this down here, though. 10 to the third, 10 to the second, 10 to the first power, and 1. Okay? So if you look right above, 10 to the third, 3 zeros. 10 to the second, 2 zeros. 10 to the first, 1 zero. It's the same problem. Nothing has changed. 10 to the third is the same as 1,000, so there are 8 10 to the thirds. 10 to the second is the same as 100, so there are 9 10 to the seconds. Okay? 10 to the first is the same as saying 10, so that's 4, and then 3 ones. Okay, expanded form. So you can have a variety of ways of writing this. It just changes based on the information you have. Okay, so the next one is 20 to the third, 20 to the second, 20s, and 1. I want you to do this for homework tonight. I want you to see if you can come up with the correct combination for that problem. Okay, and then if you look down here at the bottom at D, fill in the blanks. 113. Oh, wow, 113 looks a lot like $1.13. Blank 5 to the squared. Oh, wow, look. 5 squared is 25. Looks like a quarter to me. And then it looks like a nickel and a penny. So if that's true, then I should be able to use any of the combinations I used up here to get the correct answer down here. So I did 4 quarters. Okay, and 2 nickels and 3 pennies to get my answer the first time. This is an expanded form of this up here. It's just using exponents. With polynomials, you're going to see exponents a lot more often. As a matter of fact, you can look at exercise 2. Now, let's be general as possible by not identifying which base we are in. Just call the base x. Consider the expression 1 times x cubed plus 2 times x squared plus 7 times x plus 3 times 1, or equivalently, x cubed plus 2x squared plus 7x plus 3. All right, what is the value of this expression if x equals 10? So that means everywhere I see a 10, I substitute in the value, or sorry, everywhere I see an x, I substitute in the value 10. Okay, so here is a 10, there would be a 10, there would be a 10. So this would be 10 cubed plus 2 times 10 squared plus 7 times 10 plus 3. Okay? Now, I know 10 cubed is the same as saying 1,000 because the cubed tells me how many zeros to put in. Plus 10 squared is 100, so 2 times 100 plus 7 times 10 is 70 plus 3. And continuing on, I got 1,000 plus 2 times 100 is 200 plus 70 plus 3. Now I can add all that up. 1,273. So that's my answer. 1,273. All right. I want you to do the same thing that I just did for B. That's going to be homework again tonight as well. Okay. So part B is going to be homework. All right. Continuing on, we're going to continue on to exercise 3. All right, so when writing numbers in base 10, we only allow coefficients of 0 through 9, okay? Why is that? Okay, well, go back to thinking about scientific notation. Scientific notation dictates, so we got scientific notation, okay, states that the bases are always between 1 and 9. Okay, when we write these problems, okay, we are always writing them basically in scientific notation. So we don't ever want to go above 9 and we don't ever really want to go below 0. Okay? So when writing numbers in base 10, we only allow coefficients of 0 through 9 because of scientific notation. It is a lot easier for us to manage with a scientific base of 1 or 0 through 9 than it is to deal with 20s or 40s or 60s. Okay? So it's just more of a simplification thing for us. It's to help us out and make things a little easier. All right? Part B. What is the value of 22x plus 3 when x equals 5? How much money is 22 nickels and 3 pennies? So everywhere I see an x, I'm going to substitute in 5. So 22 times 5 plus 3. Okay, 22 times 5 is going to be 110 plus 3. Okay, so that's 113. So how much money is 22 nickels and 3 pennies? It is $1.13. All right. Part C. What number is represented by 4x squared plus 17x plus 2 if x equals 10? So we do the same thing we've been doing. Everywhere we see an x, we're going to substitute in the value 10. So 4 times 10 squared plus 17 times 10 plus 2. 10 squared is going to be 100, so 4 times 100 plus 17 times 10 is going to be 170 plus 2. 4 times 100 is 400 plus 170 plus 2. 400 plus 170 is 570. 570 plus 2 equals 572. It's just substituting and solve. This is what polynomials are all about. Okay? Now, I'm going to keep my mouth shut here. I want you to do D. Okay? This is going to be your homework tonight again. Part D is your homework. All right? So, let's look at E. Okay? E is a little bit of a funky problem, so I want us to go through this together, all right? So what number is represented by negative 3x squared plus a square root of 2x plus 1/2 when x equals the square root of 2? Okay, so everywhere we see an x, we're going to plug in the square root of 2. Now you need to remember, square roots and squares are opposites of each other. These are opposite operations. So this is what we say undoes each other. A square undoes a square root. Okay? A square root undoes a square. All right? These are opposite operations, just like addition and subtraction and multiplication and division. Opposite operations undo each other. So I got a negative 3 times the square root of 2 squared plus the square root of 2 times the square root of 2 plus 1/2. Okay, so now I got a negative 3 times the square root of 2 squared. Remember what I said, the square root and the square would cancel each other out, leaving just a 2. Plus, now, square root of 2 times the square root of 2 is the same as saying the square root of 2 squared, and we know squares and square roots cancel each other out, so we'll get back to that later on, plus 1/2. Negative 3 times 2 gives us a negative 6 plus the square root of 2 squared. Square root and squares cancel each other out, giving us a 2 plus 1/2. Okay, so now I've got a negative 6 plus 2 and 1/2. Okay, so a negative 6 plus 2 and 1/2 gives me a negative 3 and 1/2 as my answer. That's the number that is represented in this problem. Okay? Now, look down here at the bottom. Polynomial expressions. This is important. All right, polynomial expressions, okay, is either, a polynomial expression is either a numerical expression or a variable symbol, or the result of placing two previously generated polynomial expressions into the blanks of an additional operator, such as addition or the multiplication operator. Okay, that is the difference between two that's a polynomial expression. Okay, now let's continue on. Let's get to exercise 4. Okay, now this is an expanded form problem of both 417 and 231. All right, so let's watch and do this. Okay, there are 4 100s, there are 110, there are 7 1s. All right, there are 2 100s, there are 3 10s, and there are 1 1s. Okay, now the next step in this problem is combining like terms. So remember, with combining like terms, we're looking for things that are similar to each other and then adding the coefficients in the front. So I look at hundreds and hundreds. The 4 and the 2 are my coefficients, so 4 plus 2 is 6. So I have 6 100s. I got 10s and 10s. My coefficients are 1 and 3, so 1 plus 3 gives me 4. I got 4 10s. 7 and 1 are my coefficients in front of the 1s, so 7 plus 1 is 8. So my answer should be 648. So if I did the addition correctly, that's what I should get. Okay? Now the same thing is going to be occurring on these next few problems. We're looking for like terms, and we are going to simplify. So we look at each problem individually when we try to find 8 like terms, okay? So in problem B here, I got 4x squared and I got 2x squared, and I got this nice little plus, so I'm going to follow that, okay? So 4x squared plus 2x squared, okay? So I'm going to go ahead and group them together. So I got 4x squared plus 2x squared. Now plus, I got an x and a 3x, so I'm going to add them together. Now if you remember, in front of an x is always the understood 1. So I got 1x plus 3x plus 7 and 1, so plus 7 plus 1. Now it's time to simplify. We don't mess with the x squares. We just add the numbers in the front. So 4 plus 2 gives me 6x squared. Plus 1 plus 3 is 4, so it gives me 4x. Plus 7 plus 1 is 8. So I just simplified a polynomial. Okay? That's all there is to simplifying a polynomial. All right, now, when we get to subtraction, though, that's where things get a little interesting. Okay, so I need you to remember that with distributive property, there is always a number in front of parentheses, okay? When you're working with polynomials and you don't see the number in the front, okay, you got to understand that there is a understood 1 right there. And what we need to do first is we need to use the distributive property to take the negative 1 and multiply it by everything on the inside of the parentheses before we even try to do the work. Okay? So I got 3x cubed minus x squared plus 8. Negative 1 times a positive x cubed is a negative x cubed. Negative 1 times a positive 5x squared is a negative 5x squared. A negative 1 times a positive 4x is going to be a negative 4x. And then a negative 1 times a negative 7 is a positive 7. So now I can group 3x cubed minus x cubed minus x squared minus 5x squared. Okay, there's only one set of x's, so minus 4x plus 8 plus 7. So now I can simplify. 3x cubed, now let's understood that there's a 1 here, there's a 1 here, okay? So 3x cubed minus 1x cubed is going to give me 2x cubed. A negative 1x squared minus 5x squared is going to give me a negative 6x squared. There is nothing to subtract with a 4x, so that comes down. And then 8 plus 7 gives me a positive 15. Okay? I know it's a little bit of work, and I want you to practice one of them tonight, and that's what I'm about to give you. I want you to do D as homework and E as homework. Okay? We'll do F as a classwork assignment tonight, okay? So these two are your homework problems, too, okay? So you've got 4 homework problems so far, and then we got a classwork assignment, all right? And we are going to stop there for the night because I want us to do, we're going to have some work to do in the morning when it comes to some of this. So there's only 4 problem set problems, but we're going to work together to try to do these as a group, okay? So let's be patient, all right? We're going to go over a few other things in the morning. I'm hoping you guys have gotten your new Algebra 1 books. If not, then you're going to have to just be patient. We're going to work with me, and we're going to follow along the best we can. All right, guys. You have a wonderful evening. I will see you bright and early tomorrow morning. All right. Arrivederci. Ciao. Hasta luego. Whatever else we can think